We're going to part 3, and this part 3 is going to be past question. We're going to review our past question to see what is really happening. Okay, I start with 2020 stroke 2021. I start with 2020 slash 2021. Let's see what is there. So, if you look at the past question, it says it used to be two questions for 70 marks. Both of them might have 35, or one will have 40 marks, the other will have 35. But the two questions are supposed to give you 70 marks. I know in this first semester, you are dealing with mechanics and light. So one will be about mechanics, the other will be about light. One will be about mechanics, the other will be about light. So let's see from 2020 to 2021. He said, in a simple pendulum experiment, the time t taken for 20 oscillations for different lengths of the pendulum were measured and recorded by a careful student as shown in the table below. You can see the table they are showing us there. Now, evaluate mean, period, and t-square. Now, if you watch that table now, we have the first column to be for LO centimeter. The second column says time for 20 oscillation. We have T1, we have T2. They gave us value for T1, they gave us value. So in your paper now, you are going to draw out this table again. You're going to draw out this table from the beginning, just the way it is on your answer script now. Then you are going to find the mean T. Remember that mean T is T1 plus T2 over 2. It'll give you your mean T, okay? Then your T now is mean T over a number of oscillation. They say 20 oscillation over 20 will give you your T, will give you your capital T. Then if you square your capital, will give you T squared. That if you square this one, you will now get the T squared. And that will help you to fill the table. So you have answered question number A. Question number B say, plot a graph of T squared on the vertical axis and L on the horizontal axis. A graph of T squared against L. Let us linearize and see something. This T is equals to 2 pi root of L over G. So we are going to equate it to look like this. Okay, so we are plotting a graph of T squared against L. That's what they say we should do. Okay, so if we square both sides, we have T squared is equals to 4 pi squared L over G. So I think there is not, since T squared is going to form our Y, it's already here. So that means T squared is my Y axis. L is my X axis. So my slope is going to be 4 pi squared over G. There is no intercept. So the graph of this thing must come from the origin. The graph of this thing must come from the origin. A graph of T squared against L in second squared in centimeter. Okay, so the slope, the Y over the X, will be measured in second square over centimeter. That will be the unit of the slope because it is Y over X, S square over centimeter square. Okay, that is for the graph. Calculate the slope in the graph. You can do your slope when you have got your slope. It says, given the expression T square equals to 4 pi square over GL, if 4 pi square over GL is equals to the slope, yes, 4 pi square over GL is 4 pi square over G is slope. Determine the value of G. Okay. If slope is equals to 4 pi square over G, we want to find the value of G. Now, remember that you must have gotten the value of your slope from here. Let me just take an example that the value of slope I got here was 25.6 second square over centimeter. Okay, then will now be equals to 4 pi square over G. I will cross multiply. I have G times 25.6 second square over centimeter equals to 4 pi square. So that G becomes 4 pi square over 25.6, or you say G is equals to 4 pi square over what? Slope. So that is the value of G. And this G is acceleration due to gravity. This G is acceleration due to gravity. So sometimes they can ask you, what is the physical interpretation of the slope here? The physical interpretation of this slope here is acceleration due to gravity. Physical interpretation of this slope here is acceleration due to what? Gravity. Okay. Question number A, B, C, D, E. State precautions you will have to take if you perform this experiment. Now, you need to go and master 4 precautions for mechanics, 4 precautions for light. 4 precautions for mechanics. When you come to mechanics, how do you get your precautions? First of all, look at the instrument you are making use of. Look at the instrument you are making use of. You make use of the ruler, error due to parallax. You make use of your rotor stand and ensure the rotor stands are firmly tight before the experiment was conducted. I ensured I looked vertical overhead the meter rule when taking the reading to avoid error due to parallax. What again? I ensure I avoided drought by what? Closing the windows and doors properly so that all this breeze will not come and start scattering. So it depends on the reading. Now, since this one is simple pendulum, eh, the stopwatch, I ensured I use a stopwatch that is void of zero error. You know what I mean by zero error? Using a stopwatch that is okay, pointing at zero, not pointing at less than or greater than zero. So we call it zero error reading. I ensure that I use a stopwatch that is void of zero error. As many as you can obtain. Okay, now say to investigate. Okay, question number 2 now. To investigate refraction of light through a rectangular glass block, a student had made his following observation on the table. Now, you see, for the next light now, they gave you a table there. Complete the table. You can complete that table. The first place we have theta. The second we have NZ in centimeter. We have RX in centimeter. Then the next column is NZ over RX. Then the next column is cos theta. You have your theta already, so you cos your theta. Like we have 70, all those things. So cos 70, cos 60, cos 50 will be at the last end. Then NZ over RX will be at the first column unanswered, then the last column unanswered is for the cos. What is the refractive index of light? Go and cram this one. Go and find how to cram it. Refractive index of light, Snell's law, Ohm's law, Snell's law, refractive index of light, total internal reflection. Please, these things have counted. Snell's law, Ohm's law, total internal reflection, refractive index. Please go and master them. State Snell's law. Snell's law. Mention 4 precautions you also master 4 precautions for light. I've said it before. 4 precautions for mechanics, 4 precautions for light. Go and master them. Okay. The next one is 2021, 2022. Let's look at 2021, 2022. Now, let's see the questions that came out 2021 and 2022. The first one will say a spiral spring of length. Now, they gave us spiral spring of length, DO, to be 1.00 centimeter. Then I will say it's loaded with masses M, I are 10, 20, 30, 40, 50. And the length di increases. Di is 2, 4, 6, 8, 9, all in centimeter. Then I'll say respectively. Now say estimate the error in xi, which is x1, x2, x3, x4, and x5. In this case, they have not given you the table. So you have to form your own table. So I have my DO to be 1.00 centimeter. So I'm going to have my column for M column. I means 1, 2, 3, 4, 5. So I have 10, 20, 30, 40, 50. Then D, I have a column for D, which is my column for D will be DI minus DO. So here I have 2. 2 minus 1 is 1. This one is measured in gram. Please ensure you put that. So it's measured in centimeter. Ensure you put that 1. Then 4 minus 1 is 3. 6 minus 1, 0.00, 6 minus 1 is 5. 8 minus 1 is 7. Then 9 minus 1 is 8. I've gotten the column for it. So, okay. Okay, I've gotten my, then this is called X now. This is called X. X is DI minus DO. Any other thing? Okay, so estimate the error. I've gotten this. It's a plot. Tabulate your reading. Plot a graph. We have tabulated the reading. So in the reading, we have a graph of you. If you want to increase it, you can have before this one. I don't want to clean this one. You can have graph of D. D, we have 2. We have 4, 6, 8, 9. So that this one now will become the next one. That is, this one take this place, this one for just 3 column. So we are plotting a graph of M against X. You see how we got our X, see our D. This minus this will give me this. Okay. Now a graph of D against X. You know that when you plot this graph, it's a straight line graph coming from the origin. We have established that before. It's a straight line graph coming from the origin. Okay. Determine the slope of the graph. You know how to determine slope. Definitely you must do slope. What is the physical interpretation of the slope? It is always acceleration due to gravity. And listen, physical interpretation of this slope is acceleration due to gravity. It's acceleration due to gravity. Okay. State 2 precautions you will have taken if you were performing this experiment in the laboratory. This is a precaution for mechanics. So you have 4, so just give them 2. Stakes Hooke's law, you see? Hooke's law. Sorry, I said Ohm's law. Sorry, I mean to say Hooke's law. Ohm's is for electricity, while Hooke's is for mechanics. So you see, you have to cram Hooke's law. Question number 2, that one goes to light now. It says a table below shows result obtained from a ray tracing experiment using a triangular glass prism. Now, that table is there. You have to redraw this table in your answer script very neatly. Then you have D. So you want to look, you are supposed to look for D minus E. D minus E. So I believe you do that. Okay, so you say complete the table. If you are to estimate the error in slope, state the formula for calculating it. Very simple something. They say if you want to get error in slope, which formula you go use? It is standard error in slope is equals to 4W over NR. Now the formula be this, where W is you know, N is you know, R is you know, and 4 is what? Constant. That's the answer. Okay. If the intercept on both axes of the assumed plotted graph I1 and I2 are this and this, evaluate. Okay. You know that if you plot the graph of this experiment now, you are plotting D minus E over, if you plot a graph of D minus E, remember it in your over I, you are going to have the graph will go like this. So you have 2 intercepts, one on the x-axis and the other one on the y-axis. That's why I now say that if the intercept on both axes of the assumed plotted graph I1 and I2 are, now they gave us, they say take the intercept for I1 to be 56 and the arm for I2 intercept is 54. What the question now says, it says evaluate for I. Evaluate for I. We want to get I. But the formula for I is given as I equals to I2 plus I1 plus I2 over 2. My brother, I1 is 56. I2 is 54 over 2. And when you do this, you get a very beautiful answer, which will look like 56 plus 54 divided by 2, 1512. 1512. Okay, and that is the value of big I there. You say, what is a refraction of light? Because go and learn this thing. I don't want to say much about it. State 3 precautions you will have if you are to perform this experiment in the lab. Now we look at 2022, 2023, which is the last year. He said in an experiment of a simple harmonic motion using simple pendulum, the time taken for 20 oscillation for various length of pendulum L1. So we have L in centimeter. This is 350, 300, 250, 200, 150. Okay. This is for L in centimeter. They say we should the time against time T. And if you check, the time has something like this. We have to know what values are of this thing. So here, if you have 5 here, you say that here is 10, here is 15. That means 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. That means each of those small lines are 1, 1. So we have to look for the 141. That will give me 40, 40, 41, 42. This will give me 42.00. 42.0. This will give me T2 will give me 35, 36, 37, 37.0. This T is measured in seconds, please. T3 is 30, 30, 31, 32, 33, 33.0. While T4 will be 25, 26. T5 will be 20. Okay. Now, coming to the question, say read the time in seconds for the corresponding length and tabulate your reading. That's what we have done. Now, so convert your L1 to up to L5 to meters. So I need to convert this to meters. So L in meters now. It's my next column. To convert to meters, you have to divide by 100. We are converting to meters. We are going to divide by 100. So here will give me 3.5. This one will give me 3.0. This one will give me 2.5. I can add one more zero here. This one will give me 2.00. This one will give me 1.50. Okay. Then the question says calculate for period T. So remember my T is equals to small t over 20. Since they talk about 20 oscillation. So this divided by 20 will give me here. 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 Okay. Evaluate T square. Since you are putting your capital T, you can get your T square here. Plot a graph of L in meters. So we are plotting a graph of L. L in meters against T square in seconds. That graph will be a straight line graph coming from the origin. Okay. So determine the slope. You can do that. Find the error in the slope. You can 4W over NR for that. If the formula of the simple pendulum harmonic motion is T equals to 2 pi root of L over G, then they say we should find the value for what? G. Linearize this. You say that your slope will be 4 pi square over G. From here now, G becomes 4 pi square over slope. This is a workout for G. From you have to first of all linearize. When you linearize, you take your slope. So if slope is equals to this, then you make G sort of the formula and you have this. You already have your slope. 4 pi squared is a constant to get the value of your G. Okay, that ends for state precautions taken to ensure this result. Make these precautions. I've said it before. State two precautions to make ensure this number two now is for light. In an experiment to determine refractive index of a glass using rectangular glass block and optical pin. If the angle of incidence and that of the refraction is 60 and 25 respectively, calculate the refractive index of the glass. Okay. Remember that Snell's law says that the ratio of the angle of sine of angle of incidence to that of refraction is a constant, and that constant is known as what? Refractive index. So N is equals to sine I over sine R. And N refractive index equals to sine incident is 60 over sine 25. Whatever you get there becomes your refractive index. Calculate the refractive index. Okay. Question 2 there say I say state two precautions taken to ensure the accurate result. Light, two precautions for light. When light travels from air to glass, explain how light is refracted in a glass with respect to the normal. This thing is well explained here with diagram. I did that with diagram here, so look it up. Then I told you to take a little reading about refraction of light. After you browse about refraction of light, get few informations about refraction of light, Snell's law, and all those things. Then V says, what is period of a simple pendulum? Period is equals to 1 over F, because F is equals to 1 over period. So period is equals to 1 over F. Time taken to undergo what? One oscillation. So all these are things we already know. So these are things to remind you where to also spread your tentacles when you are reading. And that brings us to the end of past question in this part 3. So I believe so far so good. This revision class has been helping. So keep sending your comments. I thank most of us that have been appreciating this channel. So please ensure that you have subscribed to this channel. Ensure that you are liking the videos, please. Ensure that you are asking your question on the comment section. You can share these videos, share it, invite more friends from other schools, because this second semester we are entering, there shall be a lot of classes uploaded here in the YDX, in Physics 102, in Chem 102, and also on as my strength can carry me, so that you can have this class ahead of the normal classes. And I believe with this, all we are gearing it to is to help you improve your grades in your academic. So as you keep appreciating this platform and this channel, God will also keep appreciating you in your result. Thank you and